if I load SAM here, and then let's say that like we want, I get like an image preview immediately of like what SAM is seeing and going to segment in this image, right? So you can see I get this really rich potential label proposal. Like I'll do this click and boom, I've got most of this entire shelf labeled. I can click to add a little bit more.
Good morning, everyone, and welcome to another episode of OpenCV Weekly Webinar. It's episode 99, if you can believe it. I'm your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson, if you're nasty, but you can call me Phil, and I hope that you do. This is going to be a fun episode. Dr. Satya Malik is not here this week. He's in transit. We've got Anna Petrovicheva joining us today. We will get to her in just one moment. Our guest this week is Joseph Nelson, joining us again from Roboflow, no relation. We'll be talking about Facebook's Segment Anything model, a huge launch recently, as well as the awesome launches that came out of Roboflow's entire launch week. If you hadn't checked that out, we hope that we can enlighten you today with some of the awesome stuff that has been coming out from Roboflow land lately. But first, with me is our guest host, Anna Petrovicheva, CTO of OpenCV.ai, the consulting arm of OpenCV. Good morning, Anna. I hear that OpenCV AI just launched a new update to their website. Would you like to talk a little bit about that at the top of the show here?
Yeah, hi everyone, and thanks for joining. Yeah, we just launched our new fresh site, OpenCV.ai. Please check it out. We also put our whole portfolio there. We would be happy if you checked it out, and maybe something hits a ring, and you find something that might be of help to you.
Yeah, and it's super easy to get in touch with OpenCV.ai. If you have consulting needs or just want to have a chat, there's a one-click form on there. You can schedule some time and talk it over and see if you can work together. Thank you, Anna. Stick around after the presentation, folks, because we will be giving away to one lucky trivia winner their choice of either 1 year of the Roboflow starter plan or a Roboflow swag bag if they're in the United States. We're also taking questions from you in the audience. Please use the Zoom Q&A button at the bottom of the screen there to ask your question at any time during the show, and we will do our best to flow it into conversation, or just type your question in the chat system wherever you're watching, YouTube, Twitch, Twitter, LinkedIn. It's all good. We'll do our best to get to your questions. But enough of my yakking here. Joseph, welcome to the show. Take it away.
Thanks, everybody. Good to be here. Good to be able to discuss some of the biggest launches in computer vision. So as Phil sort of mentioned, I thought today we could do a mix of a couple of things. One is when Phil and I reached out and talked about doing this episode, we had recently planned to do our Roboflow launch week 2 weeks prior. So we were going to recap only the launch week. And then as the week got closer, the Facebook Artificial Intelligence Research Lab released SAM, the Segment Anything model, and it's kind of taken the computer vision community by storm. And so we wanted to be one of the best places to go on this episode today to get a deep dive into all sorts of enormous launches and what's changing in computer vision broadly. So I thought that no better group to discuss it with than, of course, the OpenCV crew here today. So I thought what we could do is do an overview of all things SAM and all things launch week, and then a deep dive into each of those respective areas. So we'll do a deep dive into SAM, what it is, why it's significant, how you might use it, how tools like Roboflow and CVAD and others are incorporating SAM into enabling people to be more successful with computer vision, and then a deep dive into, believe it or not, we're going to do audience choice of where the audience directs us to talk more about some of the launches and things that are live with Roboflow. So that's so for those that don't know us, at Roboflow, we build tools, open source libraries, community to enable engineers and companies to be successful with computer vision. We have tools for many parts of the life cycle and many partners along the way as well. Everything from finding and discovering good data sets in video on our open source community, to knowing what to label and be able to accelerate labeling, to doing augmentation and data set improvement, model training and prototyping with our open source model library, and hosted training for 30+ different architectures, and deployment to a wide array of devices, everything from the OpenCV AI kit, the Luxonis Oak, to devices like simple, small Raspberry Pis, NVIDIA Jetsons, hosted computes, on the edge, online, offline, all the way back to ensuring those models are running successfully and closing the loop to continue the active learning process. People use Roboflow for all sorts of things. There's hobbyist and fun developer projects like get a text when a package shows up at your door, to enterprises like Walmart using us to improve retail and their operations. I think one of the things that folks on the OpenCV ecosystem know us for is certainly the work that we do to advance the open source community and advancement within computer vision. So Roboflow Universe is a place where the community and users come together to share models and data sets to build successful models for all sorts of tasks. So if you're just getting started in computer vision, or you're just getting started with a project, chances are someone else out there has worked on a similar problem, and you can get a jump start either from labeled data sets to models. And to the tune, by the way, of, not to spoil the lead too much with some of the launches, but one of the largest places that I think you'll be able to get a jump start, where previously we'd shared, over 60 million labeled open source images, and over, at the time of this production, over 10,000 pre-trained models to get up, ready, and going. Now,
those are some spicy numbers, my friend.
We'll update here in a moment. So hopefully you're all on the edge of your chairs for big numbers, So here's kind of an overview of the process and some of the tools and things that we build along the way. But like I mentioned, our focus today is discussing big launches in computer vision. There's been a lot of things that have changed in a pretty short timeline, and I think it's only accelerating. So the areas that I think we can discuss are first the segment anything model and its overview, then an overview of some of the launches that we have live in Roboflow, which extend to open source libraries, extend to functionality and capability, extend to integrations in the ecosystem, extend to enterprise usability, and then, like I mentioned, do a deep dive into each of those respective areas. So Anna, I don't know what you think. Phil, I think we dive on into Sam.
Yeah, let's go.
Agree.
So Sam, segment anything model. So I think kind of to set the stage here, in AI and machine learning, we've continued to see foundation models, especially in the text space, and large pre-trained models leveraging transformers to provide context and awareness, understanding, and generation of large corpora of text. And we've been anticipating similar trends to take place on the vision side, and actually even with multimodality coming soon with capabilities in GPT-4. And what previously when you wanted to build, say, a given model for some given task, usually you would maybe find an initial model that might help you along with that task. You might find a model that's a good starting point, but increasingly we're going to get models that allow us to reshape and accelerate awareness of basically what computers are seeing. So zooming out, I mean, what Facebook's research team said is, what if we just trained the largest collection of data and masks on a data set to recognize any arbitrary mask? And what if we could provide zero-shot capabilities for segmenting all parts of a respective image, so that you can then use those pixels as structured data and structured information? And Sam was born. So the segment anything model came out last week. It already has a little over 26,000 GitHub stars in that first week, which I think is the fastest growing computer vision model in history. And what's really notable about it is you can use it in a variety of ways. And it's one of those foundational technologies that will be used in a wide array of disciplines. So basically, if you pass Sam an image, you can get back all of the masks for what Sam sees in that image. Like the picture here from the repository that Facebook released is an image of the trolley car. And you can see, of course, really nice segmentations around the rails, around the conductor, around the car itself, around the skyline, the buildings, individual windows, chairs, and persons in the background. And you can imagine all the rich semantic value we could create out of understanding these pixels individually. And I think the way you can interact with SAM in a variety of ways that we'll talk about. But there's no way around it. This is a huge deal for advancing zero-shot capabilities with computer vision, with advancing, improving existing computer vision preparation tasks, and with making it much, much, much faster to get going with any computer vision project, if already an existing model to use and jump from for solving some given problem.
Yeah, and one of the things here too, that's for folks that are maybe not super familiar, or haven't worked with segmentation before. Essentially, before this, you would have had to train a model to detect each one of these things individually, more or less, in this image. And the fact that it can kind of do all of them is just bananas. It's a huge step immediately. So.
Yeah, and I think that there are limitations, and we'll talk about some of those. But it is a stepwise improvement in going from I have an image to I want to understand the things and areas in this image. And as Phil mentioned, instance segmentation is especially valuable because you can get pixel-wise segments that are fairly precise of understanding what's going on in an image. I guess I'm curious, Anna, like it felt like something like this was probably inevitable, but I don't know if you thought this was a novel way to structure the task, or what you were expecting, or how you've begun to think about and reason about the release of SAM.
To me, it's a huge milestone, and it's more of an infrastructure plus doing things right milestone versus algorithmic breakthrough. So exactly like I think about ChatGPT, the algorithms are out there. It's just the guy behind them. They did everything right, and they collected truly huge and very, very representative data set to make things work. And to me, it also showcases what does 80-20 rule represent here in AI, right? So we all have seen a lot of segmentation models over the years that were trained in MS COCO with several 100,000 images, right? And they were pretty good, but not perfect. So it seems that you actually need 11 million images versus several 100,000 images to make things work here.
I think that's great.
Nutty scale too, 11 million.
Yeah, so 11 million images and 1.1 billion masks. And by the way, the data set is open source. So I think that this will only be the beginning of improving cascading impacts, because others will be able to leverage this data for their own continued models. So I think that's enough of a teaser of like, what is this thing? It's a foundation thing. We'll go deeper into the task, into the model architecture, into the applications, into the limitations in a moment. I want to give now an overview of some of the launches that the Roboflow team had been working hard on over the last 3 months or so, and sharing some of those. And then, like I mentioned, we'll deep dive into SAM to go deeper into the task in those areas. And then we'll deep dive into the areas that the community is interested in from some of the community or really any kind of launch areas. So at Roboflow, we have a strong impetus on getting things out there and making users be able to use them. And we did the last week of March themed with like each day having its own launch day theme. So the first day theme was Community Day. So I'll jump into some of the things that we saw and brought to life on Community Day. So Community Day, we announced some fun new statistics for starters, that over 250,000 engineers are benefiting from the tools, community, data sets, models that Roboflow is providing for users to use. That means over 200,000 open source data sets and over 150 million labeled images, which I think is the largest community of computers and projects and models on the web today. Some other things that we shared that I'm pretty excited about is, previously we've talked on OpenCV about the importance of benchmarking model performance, especially as the COCO benchmark becomes increasingly saturated and people use computer vision for tasks that are not represented in COCO's 80 classes. So for example, if you want to do like aerial imagery analysis or maybe underwater or biology, these are images that are, of course, important tasks to break down. But if you're benchmarking on COCO, you might not know how well your model is going to generalize to those tasks. And from the open source data sets that we've seen on Universe, we created and aggregated the RF100 benchmark. we're excited to share that RF100 benchmark is going to be a part of a workshop at CVPR, the Computer Vision and Pattern Recognition Conference in Vancouver, which for those that are in the space know is one of the foremost conferences along with ICML and NeurIPS for publishing and being aware of and driving research. So if you're going to be at CVPR, we'd love to see you there. Participate in the workshop. We're doing it in tandem with Microsoft's AI team, Google's AI team, so in the Facebook team, and many incredibly talented ML engineering teams. We also shared
that's awesome. To briefly interject, OpenCV.ai will also be there. Possibly Gary and Satya will be there. I don't know, but OpenCV will be at CVPR this year.
See you there.
Yeah, it'll be fun.
Some of the other big things in the community. So Roboflow went to South by Southwest this last year and gave a talk on building a internet scale rock paper scissors game. To complement our South by Southwest discussion, we also released a scavenger hunt app, like a little app that if you go to sxsw.roboflow.com, you can actually like try this little app out. But it basically like runs a Cocoa model on your phone.
I'll drop that link in the chat here.
Awesome. It runs a little Cocoa model on your phone to like find various objects. I think the more exciting thing here is all the code is open source. So if you want to go build your own computer vision scavenger hunt, you can. Like all you need to do is swap out the model and you can make your own thing for like your friends or community or school or company to like go find blank thing in the break room, or maybe go find these sorts of things. We launched new community features on Roboflow Universe that make it easier to like star projects. So for example, you can star a model and then find that model in other places, including other places that outside of Roboflow that you might want to use for labeling or ingestion or understanding, or inside Roboflow for transfer learning or things like this. We also introduced the initial version of a new open source library called Supervision. Imagine like a raccoon wearing a cape. And Supervision basically is like all those computer vision utilities that you often need. Once you have bounding boxes, you may want to do something like, I want to track those bounding boxes going across my screen. Or maybe I want a utility for getting the speed of something. Or maybe I want the utility for how often does a bounding box go within a given zone? Because I want to count maybe the number of people entering my store at various times a day, or the number of cars that are going in or out of a given area. Supervision basically says a lot of those tasks are built on the same primitives. What if we provide a library that makes it easy to just call those tasks via methods? So bounding box visualization and all these sorts of things. We welcome PRs to Supervision just as much as people taking advantage of using it. And I'll drop the link to the Supervision repository in the chat. At a minimum, it's a nice, easy thing to give a star and come back to later and check out all the sorts of capabilities and tutorials that are launching live there. So that's the initial kind of batch on day one of releases. Hopefully you're kind of like jotting down, this one was interesting, this one wasn't, I want to go deeper here, I don't want to go deeper here because I'm jumping to the next day. That was one day. On Tuesday, we had Enterprise Day, and we launched a number, I guess I could have mentioned on the community day, but we also launched a starter plan, an easier way to get up and going with Roboflow. And as Phil mentioned, the person that wins the trivia today gets 1 year of the Roboflow starter plan. And the starter plan includes larger limits for hosting data sets, larger limits for taking advantage of scaled GPUs, increasingly access to a hosted SAM model, which we'll talk more about, and things like this. Day two was Enterprise Day. So Roboflow is increasingly used across the enterprise. In fact, over half the Fortune 100 have Roboflow accounts. And so we're basically increasingly doing our work to support the enterprise in being successful. So that means things like we now have SOC 2 Type 1 compliance, which compliance engineering is no small joke. I'm sure folks that have been a part of teams know the level of effort that it takes to make that be possible. Another thing is Amazon Web Services recognized Roboflow as a machine learning competency partner, kind of a select group of companies and organizations that they can rely on for delivering machine learning services. We announced the ability to run more of Roboflow self-hosted. And in fact, in Roboflow fashion, a complementary open source project so others can do the same. So for example, if you want to migrate your Firebase project to Superbase, we created a shim called SuperShim that you can use to do similar. The last thing here was advanced annotation features for larger teams, for the ability to have increased QA and review, for understanding of annotation productivity, and all these sorts of things for things that we've been hearing from customers and people that want the ability to do. So basically, while the first day is like Roboflow is here to basically make sure computer vision can be a ubiquitous capability, day 2 is, and we're open and ready for business to make it easier for your company to be successful. Day 3, dataset day. We really went deep on basically areas where we can provide better utility for people to understand their images. Why is my model working? Why is it failing? What are patterns of things that I might want to label next? And tools around this. So one really popular set of features here that we released is every image that you upload to Roboflow in your account gets clip indexed, the contrastive language image pre-training model from OpenAI. That allows you to do rich semantic search on those images. Those clip vectors are now exposed via API. Why does that matter? Because you can do deep embedding analyses. So you can say and see and look, what cluster of images are most similar to another cluster of images. And here I'm going to minimize my screen and go into that specific launch because I want to troll Phil with the way that we launched this blog post. So I was talking about the vector analysis. So for example, if you wanted to take the Never Gonna, a very good song from Rick Astley, and you wanted to break down all the frames in a given song and see like how similar or different it is, that is in fact what we did here. So you can see all of Rick Astley's different and greatest hits and the different scenes from his various videos. Basically what you're seeing here is the cluster of points of the embedded space of which images are similar, which images are different. This allows you to do things like, are my trained valid test splits actually representative of one another? Which images might I want to label next? Do I have anomalies in my data set? And all these types of things.
Anatomy of a Rickroll.
Anatomy of a Rickroll. That's why you're the content guy. It's a better title.
You're welcome, buddy.
So yeah, that's like a fun sort of demonstration of that capability. Some other things that we included on Dataset Day include improvements to the command line interface, so you can more easily interact with Roboflow via API for moving data in, moving data out, pulling it into your environment. We also added initial features for supporting GPT-4. So GPT-4 is going to increasingly be a theme for AI and computer vision and text more broadly. Notably, GPT-4 today has text access and soon has multimodality access. Roboflow is fortunate to be backed by the co-founders of OpenAI, so we're really apprised and stay on top of the things that OpenAI is releasing and putting out. So for example, with GPT-4 today, you can use Roboflow to better understand and make sense of your data set. Basically like automatic README generation of like what's in my data set, or better filter sort based on what GPT-4 understands about your data set. We also released the world's most helpful support agent. And you can chat with him now if you're inside the Roboflow app. His name is Lenny. He's powered by GPT-4, and he knows everything on the Roboflow 480 blog posts, 120 YouTube videos, dozens of open source projects and documentation, way better than anyone on the Roboflow team can for providing immediate Q&A. And the last thing here is you can comment on images with one another if you're trying to review and QA given data sets. So
I've got to ask, why Lenny? Is it, please tell me it's named after Lenny Leonard from The Simpsons.
The origin story of Lenny. This is good Roboflow lore. So Roboflow participated in a startup accelerator called Y Combinator, and there was another member in that startup program named Lenny. And Lenny liked to poke fun at the Roboflow YouTube videos, and a certain Roboflower in particular that got animated on said Roboflow YouTube videos. So Lenny, in partnership with a friend, made a remixed song is a generous term for mashing together all of Roboflow YouTube. And what I'll say is a lot of Roboflow YouTube began with me saying, "Hey there, it's Joseph from Roboflow." And this is sort of like a dubstep mashup of that. I quickly tried to expunge that from the internet. It's still out there, unfortunately.
Yeah, good luck with that.
But basically, it went like mini viral amongst like YC. People were like, "Oh, are you like the dubstep guy?" And I'm like, "That's not, no," but it was too late. So
like, I sure hope not.
So we said, you know what, Lenny, that's a funny impact to honor that. Lenny the raccoon, and raccoons, of course, are kind of very mischievous, fun sort of creatures. So it all kind of wraps into this sort of story.
That's funny. On my side project, the indie, public domain, indie media thing, Retro Strange, I call the fake janitor Leroy. So there you go.
That's good. Leroy and
Fun
Lanny.
facts. Yeah, they're drinking buddies, I think,
They go to the same dumpsters.
and complain about their bosses.
All the above. All right, day 4 was deployment day. So as mentioned, over 50,000 models have been trained and ready with Roboflow. So on deployment day, we enabled people to basically upload many different model types. So if you've trained like a YOLO V7 model, YOLO V5 model, YOLO V8 model, and you have instant segmentation task and object detection task, you can upload these and then you can immediately benchmark it on your data set. So once it's uploaded, you can version it and see, oh, I trained this in a Colab notebook. I don't want to lose those weights. I want to refer to them later and immediately have them available. And any of those models that get uploaded are immediately ready for deployment. So for example, like an auto scaling, instantly available, always on API, and also like edge deployment. So you can basically take that model and run it immediately on a Lexonis Oak, immediately on a Lexonis Jackson, in an optimized runtime, so that you can basically upload model and then plug in device and have your model running on that device at an optimized runtime with relatively low overhead. You can even also have that device automatically see model points of failure. So this is basically a way to support and make it easier for all things deployment and understanding of ease of use of different models. As a part of that, that includes the updated Roboflow inference server. So basically, we released a inference server that you can take and host on your own environment, in your own cloud, or you can have Roboflow's cloud host it for you. You can deploy it to these edge devices. That inference server includes things like optimized runtime, monitoring of the model to verify performance, and the ability to basically swap in and out models. So for example, if a new upgraded model comes out, and you don't want to go through the work of recompiling and redoing it, you just change, 8 alphanumeric characters, and your stuff just kind of continues to run in a seamless, nice way. We released Clip in the inference server. So the same technology that powers the semantic search at Roboflow is available for anyone. So you can basically spin up and use Clip immediately. The last thing I'll share here is perhaps folks saw the Grounding Dino launch, which is a zero-shot object detection model. And that enables you to basically have a notebook and the ability to create useful initial predictions from given models. That's on the Roboflow's notebooks open source repository. I went ahead and dropped that one in the chat. I think that's our highest starred repository. Definitely give that a look if you haven't already been following along with all the open source models. Piot on our team, many of you all know him on Roboflow YouTube, does a fantastic job of giving overviews and awareness to those capabilities. Last but not least, ecosystem day. So this is where we highlighted a lot of things that we're working on with integrations, partners, other tools, empowerments, organizations. So we thought about calling it like integrations day because that's largely what it is, but then there were some things that also like are just general like ecosystem-y things. So for example, we launched and highlighted during the last quarter an integration with CVAT, which Anna is an expert in, of course, and runs the CVAT team. So CVAT and Roboflow, so all the models that exist on Roboflow can be used for auto labeling on CVAT today, which means you can go find a useful model and then use that in your CVAT labeling project and immediately understand. I think we're also going to have some additional coming integrations to make it even easier once you have data labeled in one of them to then go deploy and pipe data back. But I won't put Anna on the spot on when we plan to do some of that stuff. The other things that we have are an integration with Zapier for no-code computer vision workflows. So for example, like if you want to have, I don't know, whenever there's a package that shows up, you want to set up a Zap that then texts you using Twilio, or whenever you have a image of a raccoon in your backyard, you want to get an email, or you want to email Phil when there's a raccoon in your backyard. All of that's now immediately easy to be wired up with Zapier.
It is unfortunately very easy to do with my very public email address of phil@opencv.org.
But you heard it here first. You got to build a raccoon detector with Roboflow and then email it to phil@opencv. We also,
Gosh, I would hate that. Don't do that.
we also introduced the ability to do increased synthetic dataset generation with a couple of different tools. So one is with NVIDIA's Omniverse. And actually, if you saw the NVIDIA keynote, NVIDIA actually highlighted some of the tools that they've been working with, one of which was Roboflow for easier creating synthetic data sets. We also released our an example of, we have an open source way of producing copy paste augmentation, where you take an object and you paste it onto a new scene. We released a hosted version of that called Magic Scissors. So Magic Scissors, as maybe the name implies, cuts out one object and pastes it onto another. I kind of think about it like if fifth grade me were like in crafts class and trying to make my own data with construction paper, Magic Scissors is the digital form of that. And other additional integrations with other labeling tools like Make Sense as well. And lastly, we launched verified organizations on Roboflow Universe. So folks like Intel have verified organizations for basically meaning that you can find things that Intel is sponsoring or models that they find interesting or particularly useful. And speaking of, we actually need to get OpenCV's verified space, the workspace and projects live across Universe.
Before we move on here, you mentioned scissors, so I have to remind the folks out there that everybody loves the acclaimed.
Are you always a scissors on rock, paper, scissors? Yeah, so that's the rundown of 5 days. Thanks so much for giving a gander to those things. Hopefully you have some notes of places that you want to run deeper. I know Phil, our excellent moderator, has probably been seeing the chat of questions that are coming through.
Yes, indeed.
Before going deeper into these, I think it'd be awesome to go deeper into SAM. So that's where I think we go next. Anna, what do you think?
I think this is incredible, the work that you do for the whole ecosystem and to generally democratize how AI is being used is incredible. So huge kudos to you and the team.
Thanks so much. Thanks so much. Yeah, I mean, what do you think about going to SAM? But I will happily take the compliment as well. I super appreciate that and wish I could take the credit, but of course there's
the chat is thirsty for more SAM apparently.
Awesome. Let's do it. So we've published some good content on SAM that I'm going to jump to talk about the task, the data set, and the model architecture. So let's, I think first things first, I kind of wanted to give an overview to like the fast facts. So as discussed, Segment Anything said, what if we took a massive data set of well-labeled, cleanly curated data, 1.1 billion masks, 11 million images, and we trained a model to recognize each of those masked areas on a larger scale with higher quality imagery. What would we sort of get? And SAM is the result. So the Segment Anything task is, given an image, can you find all of the, call it mask proposals, or the areas where there's going to be a meaningful region of interest in a polygon instant segmentation way. So I think maybe it'd be interesting to dive into a little bit about the model architecture. So here's what's notable about Segment Anything as a model architecture. Anna made a good point. She noted that there's not a huge model breakthrough necessarily here. It's largely taking some of the advances that exist in transformers and associated encoders and applying them to vision, which is exactly what's been done here. So basically, the model architecture is a image encoder that's where all the pre-training takes place. So at the time of training, this encoder was trained to say, given this image, come up with some proposals of where masks could exist in this given image. That's where the bulk of the data set was extremely useful. That's where the large scale compute became useful. And so once an image comes in, it goes through this image encoder backbone and leaves with image embeddings. So then the user, or I guess the person that's interacting with the model, is left with the requirement to propose or suggest which masks they're interested in interacting with from this image encoder, right? So if an image comes in, you get all these masks. And that's kind of what we were talking about on this example image, right? We have all of these masks, but the way you interact with these masks is quite important. And so there's two ways. There's two ways that SAM proposes interacting with with the mask proposals that come out of image encoder backbone. There's the ability to do it with actual just prompts, where you can, initially the paper actually discussed trying to get the text prompting fully working, or you can propose even regions of interest. So you can say this area, this mask decoder is where I'm interested in getting a bit more details and understanding from what's going on. So to give an example of that, let me highlight to you, we have a Colab notebook on how to use SAM, and I'll put this in the chat for sure. So in this Colab, you basically have the ability to load Facebook's segment anything model. You load up the supervision library for doing initial proposals of a mask. And then here we have the source image where Piat and his dog, and you have the segmented image of what's proposed. Notably, if we look under the hood here, you actually get all of these proposals. You get all of these proposal masks. And that's what we're seeing at this portion of the decoder, is all these suggested potential masks for this given image. So notably, for example, you see you kind of have different examples of the dog, and those get deduped, but you can actually query and interact with SAM to get those regions of interest. Now, this architecture means that there's kind of like two notable things as it comes to using SAM. The image encoder portion of the model is very compute intensive. You'll benefit most from having a GPU to conduct the image encoding in a compute efficient way. Once the image encoding has taken place, you can do the decoding from prompt or from mask selection in a relatively compute efficient way. So to make the most use of SAM, it is, even at inference, it's going to benefit a lot from having a GPU, or at least a high power compute. I haven't yet seen folks getting it running super performantly on an M1 yet, but I'm sure that folks have done that, and more of that will become soon. But I don't know like what performance roughly to expect. But it is a somewhat heavy model, which also kind of limits all the places that you can run it for now, in terms of like edge or other considerations. So that's a bit on the model architecture. Anna, I'd love your take on what you're seeing and what you're thinking about from reading the paper and getting a suggestion of what the architecture suggests about SAM.
Yeah, so I just wanted to get back to my initial comment about SAM. So even though there are some specific, very unique parts about SAM, SAM's architecture and algorithms, I do believe that it's mostly an infrastructure and data achievement than algorithmic one, right? And all these, parts that we see there, they are pretty much, standard for the industry, state of the art. It's a very, very well thought out and executed thing to do, to kind of combine all the pieces together and just make it great.
Yeah, I think that's a really good call out, is that like just doing almost like the right thing with like data prep and structuring of the task, just as important as getting things right. Now, one thing that I'll call out as a limitation of SAM. So one that we noted was, it's a relatively compute intensive model, even at inference time. And it's a relatively large model too. There's 3 sizes that were released, and the smallest one was 375 megabytes. That's not massive or particularly say prohibitive, but just given the compute that's required, getting it to run performantly on an edge device may be difficult. And then the medium-sized one is 1.2 gigabytes, and the largest one is 2.5 gigabytes, which I think we have in here somewhere. Now so a limitation is, it is relatively compute intensive model, which makes it difficult for some of the places that you can run it with expecting high performance. So for example, like running SAM real time on like an iPhone is not here yet. Though certainly this creates some of the background for what might be possible. Which I think actually means there's going to be a meaningful opportunity to take what SAM knows about your data set, turn that into a useful data set, and then train your own slice of the world, so to speak. So if you basically if you wanted a model that's going to find, we'll say like trolleys, you of course could pass SAM and get all this other information, all this data. what you could also do is get all of the trolley and then just kind of ignore the rest of the labels. And then it's almost like it's not true distillation, because you'd basically be taking what Sam knows, putting it into a data set, and then training your own smaller like single shot detector to run on the edge. But I think this is going to be a growing trend. In fact, in the way that with foundation models in natural language processing have progressed, there's been a lot of examples where, you know, GPT-3, GPT-4 can do code extremely well. They can also do a wide array of other tasks quite well. For if you're building like a code completion tool, you might want to quote unquote distill down, or at least take what these large models know and create your own model that you own, that's your IP on your data that you can run where you want to run it, and compress that information down into your own ability. And that's actually some of the things that tools that we're working on, and I think trends will continue to happen, is basically use SAM to extract what it knows about a given area, region, and then turn that into a data set you can use in a wide array of other sorts of tasks and abilities.
Another trend that I actually expect is, I think people are going to take the data set and train very small models on it, right?
Yes.
And it's going to be a whole new kind of state of the art in semantic segmentation, because the data is like super valuable, and Meta basically donated it to open source.
Exactly. So Sam knows a lot about a lot. You might need to know a lot about a little. So you could basically take the data sets, or even what Sam knows about your data set, and train your own smaller specific instance segmentation, or even object detection model. I think something that surprises a lot of folks that I hear commonly is you can use instance segmentation labels to train an object detection model. And you might want to do that if you want, say, the performance of object detection, or you're maybe a bit more compute constrained, or something like this. So that brings us to the data set. So the data set was curated in 3 steps. I think this is a really cool part of the paper. One was they did assisted manual, where annotators worked alongside Sam. The second was semi-automatic, where the annotators worked to say what, basically correcting Sam. And then the third was full auto, basically using Sam to create more training data for Sam. And this sort of like scale up is I kind of think about this as like agile development applied to ML dataset generation. This is a trend that we see being very popular at Roboflow for any sort of data set. Is, you know, instead of saying I have 10,000 images and I need to label all 10,000 before I do anything, start labeling 500, train an initial model, then use that model to label with you for the next 1,000, 2,000, and retrain. And you basically kind of, you know, a student-teacher model where the student is the model and the teacher is the human, to basically continue to increase the competency along the way. And that's exactly what Sam did. And I think that is a replicable technique. Awesome. Should we talk about some use cases for Sam?
Yeah, definitely. Folks are enjoying the deep dive here. Let's keep going.
What Anna, what are some things that you think Sam opens up as capabilities?
It might be obvious, but people are still struggling with object detection. And even though this is a segmentation model, it basically solves detection too. So some things about object detection that were hard to do so far, I think will be progressing a lot with segment anything. And I'm talking about some industrial applications like understanding what is your warehouse like, understanding its geometry, where people are, do they wear, you know, helmets or not, stuff like that. So fully understanding the semantic of things and being able to later track them. Another thing that I'm super interested in is being able to understand the rich semantics that segment anything understands, right? Like very diverse types of objects, that actually opens up new opportunities in retail, I think, where it's pretty hard to understand everything that is going on for example, product shelf, right? So I think retail will also be enjoying segment anything a lot in the upcoming months.
Really good call outs. I think actually warehouse in particular would be a fun one to look at. So for example, like one of the use cases, so you could use Sam basically as a standalone thing where you don't use Sam to prepare data at all. You just use Sam as a model. And so if, like, for example, like you could build a background removal app with Sam very quickly. You could build a explain what's in this photo app or understand this room app, or you can get pretty high fidelity of just an understanding of SAM. One limitation that I forgot to mention previously with SAM is SAM gives you masks, but doesn't name those masks. Not yet. So you have to combine SAM with something else for now to also get named masks. And so you could name those masks, you could use it to if you're preparing data to label data, or you could combine SAM with another model like grounding dyno to do zero shot label or describe this area, this mask proposal to say what it is. Yes, and Anna.
Yeah, so I just posted, I just posted a repo that you guys might find helpful here. It's a combination of ground and dyno with segment anything that basically does that.
Exactly. So the IDEA research team, which put out grounding dyno, came to this exact same conclusion, which is we can use SAM's mask proposals with grounding dyno's awareness to make proposals about labels and candidates in a zero shot way. They even show doing it with stable diffusion, some other types of capabilities, which I think is super exciting.
I've actually never heard of. Can you talk a little bit more? What is dyno?
So dyno and grounding dyno were produced with the intent of being open set, zero shot, text guided object detection. So you could text prompt to find things in an image, was the goal and task proposal with dyno. It's a little finicky of getting your prompt right to get the right sort of things, but it's extremely powerful. It's extremely powerful, especially when combined with something like SAM. And we're actively, just like Anna shared, working on examples and tutorials that will basically radically accelerate data preparation with the combination of these sorts of techniques. Another way that you could use SAM to accelerate your capabilities, right, is in addition to using it maybe zero shot for applications, is also annotation, which you could use those annotations for, of course, instance segmentation or directly for object detection as well. So I kind of want to give a shout out here. So there's previously been tools, ours included, that have smart polygon proposals, regions of interest and smart polygon proposals. I kind of want to show what SAM affords us that previously wasn't as, basically show the stepwise improvement of SAM performance on some given image example. So for example, if I load SAM here, and then let's say that we want, I get an image preview immediately of what SAM is seeing and going to segment in this image, right? So you can see I get this really rich potential label proposal. I'll do this click and boom, I've got most of this entire shelf labeled. I can click to add a little bit more to basically make sure I get this whole shelf region. And then just like that, I'll just say shelf. I've got my shelf, and then I can just do another quick shelf. And just like that, different textures running on different areas of disjoint area. And it's, that's done. It's labeled.
It's really impressive shit.
Yeah. And so so what's nice is that we can also, we can do these candidate proposals of what you're going to see when you actually create the box of interest. So here it's okay, that box is going to be the exact, or that polygon is going to be exactly what I want. Let's jump to this other image and basically compare the two. So that was SAM. Let's show the prior kind of state of the art for this technology. So if I want to do the same thing where I click this area, it's a little less perfect. So I could say, no, I don't want this portion. I don't want this portion. I don't want this portion. Okay, now it's honing in to get a little bit better. I do want this portion. I do want this portion. And here so there you see it arrives, kind of arrives at a similar position, but it's not as precise as something like SAM. So let's switch back to SAM for the bottom shelf. The other thing about SAM is that we can load these proposal candidates right out of the box, right? So here I see what I'm going to get before I click, and I get shelf. So this is live today in Roboflow. Anyone that wants to go use SAM and have the enhanced capabilities of seeing candidate proposals is live. I know that CVAT also has SAM integrations live today. The impact of SAM for dataset proposal is already immediately becoming impactful.
And you cannot believe how many requests we got from community before we did that. And it's been only like several days after the launch.
Yeah.
So that's incredible.
Exactly. So I think it's really, people recognize just how momentous this is going to be. I also, you know, before the show, I tried out my little background here, and I was like, you know, let's see what Sam will have to say about the regional proposal and candidates of interest. So here you can see, like, I can do this. What's really interesting, right, is that, like, let's say I get this proposal. Something that's nice about the interactive ability here is I can say this proposal, but actually I only wanted my shirt. So I'm going to say, no, I don't want my face. And boom, with the negative point and the positive point, it knows that here, you know, you just wanted, in this case, shirt. Here I got a little surfboard. I'll say surf.
Cowabunga, dude.
Yep. And so here with the previews, I can get a sense of, like, maybe I wanted the whole plant. So I can kind of mouse around to see if I can get a proposal of maybe the whole leaf, so the whole plant. I see I'll do this leaf, and then maybe I'll add another leaf, and boom, whole plant. So the impact of SAM and the way it's going to accelerate is awesome. So here, maybe you recognize this logo. I'm going to say cool logo. Nice.
You're maybe a little bit biased.
Okay, fine. I'll remove the bias from my model. I will just say this is just going to be logo that Phil doesn't like. No,
I mean, it's fine. Don't put words in my mouth. Now is the time for our weekly trivia giveaway. This week, Roboflow has been kind enough to offer up, you know, should we do 2 trivia questions today? One for swag in the US only, and one for Roboflow starter pack global. Okay, we'll do the swag pack first. So I'm going to ask 2 trivia questions, first one, then the other. You will have the opportunity to answer one of those questions in the Zoom chat window here during the show. If you have won in the last few months, please do not answer and give someone else a chance to win. The first person that answers correctly will win the Roboflow swag pack for this question. Please don't answer if you're not based in the US, because we got to ship stuff and it's kind of a pain to get stuff to some of the far-flung locales that our global audience lives in. But the question after this one will be for the global audience with 1 year of the Roboflow starter set, or whatever it's called, starter plan. Get ready to answer here. What is the name of the Roboflow raccoon? Oh man, Seth, just bing. Congratulations, Seth Johnson, our winner for this week's trivia. Just got it right out of the box. The answer, of course, is Lenny. Lenny was the answer we were looking for there. Seth, please send one email to phil@opencv.org. and I will make sure that you get your Roboflow swag pack. Second trivia question today is for 1 year free of the Roboflow starter plan, a huge value. Thanks, Joseph, for putting that up today. Get ready to answer. And again, if you have won recently in the last 2 months, please don't answer. Give someone else a chance to win. The Segment Anything dataset has how many million images in it? Oh, so many answers. Man, the folks were ready for it. Cal Marshall, or Cal Marshall, I don't know how you pronounce it, was the first one to say 11. The answer is 11 million. Please also send one email to phil@opencv.org, and we will make sure that you get your Roboflow starter plan for 1 year for free, thanks to our generous guest, Joseph Nelson. We've got a couple of interesting questions here. An anonymous attendee was asking about how does SAM deal with occlusion? Like, say if you're doing even just a single image, the entirety of something may not be visible, but most of it may be visible. How does it deal with that? Like, and maybe for successive frames of video, for example, like how would it deal with tracking stuff like that?
SAM has the concept of occlusion. So here's a likable example. So I'll turn on SAM. So for example, like, this dog here is occluded by this balloon. There's many balloons that are occluded from one another. You can see Sam makes candidate proposals of just the portion of the object that is not occluded. So here I can, just do like that sort of balloon. And you get a sense of like what Sam sees, what it proposes for what you can do. Now, I mean, we could try something like maybe like we want like all these balloons to be like a single thing, so we can just like add a bunch of the balloons together. Maybe if that's what you were after. But Sam by itself generally has the awareness of like start and stop boundaries of things. So I guess the way that deals with occlusion is hopefully as close to how a human would think about occlusion. So maybe another one here is like this apron is kind of interesting, or it's partially occluded by his arm. And here you see that the candidate proposal is just the apron area. So it doesn't, for example, include the area here. It just looks at the area where it thinks it sees the apron. So that's how Sam thinks about occlusion.
All right, great answer. Yeah, it's wild how, yeah, I mean, this is a really big step for so many things. So Swati asks, how is this different from SegFormer? I'm not familiar with SegFormer, but are you?
Yeah, SegFormer is a transformer-based architecture for doing zero-shot semantic segmentation. And it kind of represented a similar approach to this same task. As the name implies, it does semantic segmentation, so it tries to assign every single pixel, I believe, to a candidate class, whereas the model in SAM is instant segmentation affiliated, which means that it doesn't need to assign every single pixel to a class. It's also in my experience. So recall how we talked about that the architecture differences. SAM does the encoding, and then you create proposals out of the image encoding in kind of like two distinct steps. SegFormer, there's not the similar, you don't query for all candidate proposal masks. And so it just runs through the full model, which ends up being a bit more time intensive per inference. And you can't do things like create candidate proposals of individual images. I believe we have SegFormer in, yes, instant segmentation. Oh, so actually it does have instant segmentation, not just semantic seg. But yeah, so SegFormer, I think also is slightly weaker, just given the scale of data sets and capabilities.
Is it, somebody else asked, is SegFormer maybe more performant on edge than, say, for example, segment anything, maybe?
Don't recall. So SegFormer is also quite large. I don't recall the size difference. I'm not aware of folks getting SegFormer running on the edge, but it's still a quite large model. Yeah, here we go. Yeah, so, still a 64 million parameter model. I haven't seen SegFormer on the edge. That doesn't mean that people aren't doing it. But yeah, you get the masks, candidate masks out as semantic segmentations as well.
Nice. Yeah. So this one's for me. What's the weirdest thing you've seen people doing with segment anything so far, just in the few days that it's been out? Anna, you first. Have you seen any kind of interesting, like, oh, I didn't think of that lately?
Probably no. So all the things that I see how people use segment anything are kind of interesting to me, not weird. I haven't seen anything weird so far.
No oddities yet.
Not yet. So I've seen a lot of people use it for anime or manga. And I don't think it's like super great for it. I think there are better things to use with anime. But anyways.
Yeah, well, like with manga, I mean, it's just black and white, right? Like you don't really need a lot of
very cartoonish, right?
Yeah. Joseph?
I think there's still a lot of applications to be built. I haven't seen anything super weird, strange yet. It's a lot of things you would expect of like improving data set curation or background removal. But I think that the things I'm pretty excited about are almost like instant model generation. Like you could like say like I'm interested, like you tell Whisper, I'm interested in all plants, and then transcribe that, turn that text prompt into something to guide grounding Dino, take all the candidate math proposals from from an example model from Sam, and then have like a model that comes out on the other side that does that for you. So I think that like the stringing together these technologies is only going to get more weird and powerful.
Yeah, I think there's a lot of you're going to see a lot of really cool stuff of people daisy chaining these things together. Like I think, yeah, when you individually they're really interesting pieces of technology, but when you're able to really easily just duct tape them together within, a trivial amount of time, it unlocks a whole bunch of other things. And so, yes, it's really exciting. I'm thinking like, man, why have I not already built a video game cartridge detector that then looks up the label and see how much it costs on eBay and all that kind of stuff. I think that just became like a weekend project instead of like a couple of months project, and so really interesting stuff. Yeah, so somebody asked in the chat if we could see a little bit more about magic scissors. Do you want to maybe take a look at the magic scissors for a few minutes before we call it a day, Joseph?
Yeah, let me just give you a quick overview of what that does. So magic
Yeah.
scissors is basically this idea that we could zero shot produce example useful synthetic data. So I'll show you the like open source code version, data sets, Roboflow, and then I'll talk you through what magic scissors does. So basically, so if you wanted to if you had some images labeled, but you want much more images, maybe of an underrepresented class, like let's say you're building a fruit detector and you have a lot of apples and oranges, but not bananas. If you have masks of a given
if that was the case, you may have some scaling issues.
No bananas, no scale. That's right. So if you have like masks for given objects, which now with SAM are super easy to produce candidate proposals, the idea is that you could take those nice masks and paste them onto a new background. So for example, like Google's open image dataset could be like the background of interest. And so in this example, like we pasted fruit on top of open images, which produces some funny looking stuff. But of course your backgrounds could be anything. And so this guide walks through the open source way of doing that. What Magic Scissors is an app that does this in a hosted way. So magicscissors.app, all you do is you say, here's the data set of masks that I'm interested in, here's the data set of backgrounds, click go, and then it pastes them all on top of each other and gives you a fresh new data set that you can use in interesting, useful ways.
Very cool. Very cool. Yeah, we're about six after the hour. I think we can probably call it a day. I mean, we had some more slides probably, but I feel like we covered a lot. What do you think, Joseph?
I think we're in a great spot. Yeah, I mean, there's a discussion live on Hacker News about SAM and Roboflow now. If you want to continue the conversation, I guess it's under newest. I'll just throw that in the chat.
Sweet.
I'm Joseph of Iowa everywhere, Twitter, whatever, and Roboflow is probably the better way to find me.
Yeah. Any final thoughts for today, Anna?
I just wanted to generally comment on how fast things are evolving, and things just like you said, right? Things that would take several months to do with an uncertain outcome. Right now, just are projects to execute, right? And I expect a lot of products to be created out of SAM, ChatGPT, and other models that we have just discovered recently, right? A lot of things that will make our life easier and more fun.
Yeah, I totally agree. I think there's also the flip side of that, though, is that like with all no technological innovation comes without a price, and I think what what Segment Anything just did was turned a lot of startups into features. And I think, a lot of people that maybe just got funded or are trying to get funded just had their funding explode because what they're doing is no longer novel or all that useful because of Segment Anything. But that's the trade-off, that's the game you play. Joseph, any final thoughts for us today?
I'm excited as ever. I think Anna nailed it, that like the rate of acceleration is going to only continue to increase. It's going to make it easier to make the world read, write, access, as we say at Roboflow, make things programmable. While SAM is live today for improving labeling stuff, we'll also have hosted SAM available very soon if you just want an API to call and on the deploy side and build apps on top of it, zero shot. So looking forward to empowering all the amazing creative ideas that people always seem to have, and nothing but gratitude for folks contributing back to the community with their amazing projects.
Yeah, really big ups again to the Roboflow team and the Roboflow community. It's really amazing to see the not just the growth, but also the diversity of stuff that is on like Roboflow Universe, etc. It's really impressive to see. Always love having you on the show. Thanks so much, everybody, for joining us today. This was a fun episode. I hope it was fun for you as well. I hope you learned something, and I hope you will join us again next Thursday, same bat time, same bat channel, where our guest will be talking about the OpenCV Model Zoo. We hope you will join us then. I will see you there. Take care of yourselves out there, everybody, and take care of somebody else if you can, and have a great day wherever you may be. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.